Now that we've did various calculations about pH and where we are in our titration curve, let's go ahead and construct this titration curve for a weak acid and a strong base. So the pH before adding any base is going to be 2.83, which is indicated by this point down here on the graph. When we add 10 milliliters of our 0.1 molar sodium hydroxide solution, our pH is 4.56. So it's going to be right around here. Okay? When we do 12.5 milliliters of sodium hydroxide, our pH equals 4.74. Okay? Then when we look at the pH at the end point, that would be adding 25.0 milliliters of sodium hydroxide. Our pH is going to be 8.72. Then when we add 26.0 milliliters of sodium hydroxide, our pH is 11.29, which corresponds to this point in the graph. So here's our particular titration curve, and what we're going to see is we're going to see a slight increase in the pH until we reach the endpoint. Once we reach the endpoint, we're going to see a steep jump in pH, and then it's going to tail off just like it did for our titration curve between a strong acid and a strong base. When we look down here in this area is going to be the buffer region. But remember that buffers only work over a certain, buffer capacity, and then we're going to see a steep jump. Okay, here is our equivalence point. And remember, at the equivalence point, the moles of H plus are going to equal the moles of OH minus, and the pH of the equivalence point is dictated by the pH of the salt. And since we have a weak acid and a strong base, it's going to be basic. So this will be basic for weak acid, strong base titration. Okay? Then, after the endpoint, the pH increases due to excess OH minus ions here in the solution. And one of the main differences here between or in comparison to a strong acid, strong base titration curve, this change in pH near the equivalence point, this steep line here, is going to be much smaller compared to a strong acid, strong base titration. And I should say the change in pH here is going to be much smaller than our strong acid, strong base titration. So this gives all the various points that we're going to be interested in when we look at a weak acid, strong base titration curve. And the same thing would happen for a weak base, strong acid titration curve. And we can do examples of those in the homework, but this will kind of wrap up what we wanted to accomplish when we talk about various titration curves, and we can have them from strong acids and strong bases, weak acid, strong bases, and strong acid, weak bases, and look at the various effects of each of these titrations.